you're a junior to mid-level developer looking to build REST APIs like a senior, stick around because in this video you're going to learn how to do just that. In this tutorial, we're going to build a REST API with Node.js, TypeScript, MongoDB with Mongoose, and Express. We're going to cover some theory along the way, and we're going to be doing a whole lot of practical coding. So who is this tutorial for? This tutorial is for any junior to mid-level developer, or anyone who wants to build out REST APIs with TypeScript. So why would you want to build a REST API in 2021? Well, REST APIs are still the staple of the web development industry. Knowing how to build REST APIs is important for both back-end and front-end developers, and there's no better way to learn than to build one. So the concepts that we're going to cover are REST API principles. So we're going to have a look at CRUD, HTTP methods, what a REST API is and is not. We're going to look at JWTs and refresh tokens. The technologies we're going to use to build the API is Node.js, MongoDB with Mongoose, TypeScript, Express, and Express middleware. So we're going to start off by having a look at what it is that we're going to build. We're then going to bootstrap the application. We're going to build out the registration, and we're going to build out the CRUD operations for our post objects. So we're over here in Postman, and we have a REST API tutorial Postman collection. And the first endpoint is to create a user. We can hit this endpoint here and we get our user back. The next endpoint is to create a session, and this is to log the user in. So we send along our email and password, and we get back an access token and a refresh token. So we'll take this access token and put it into our environment variables. And we'll do the same with the refresh token. And if we hit this get sessions endpoint, we can see all the sessions that this currently logged in user has. So we can see that the time that they logged in, the user agent that they logged in from, and this array will show you how many sessions that user has and whether the session is valid or not. We can create a post. And after we create a post, we get a post ID, and we can set the post ID in our environment variables. We can update our post, and finally we can delete our post. So there's a few different ways to structure a REST API. Some people will structure it via the resources, so they will group the controller, the model, and the service all together for a resource. I like to group the folders via what they do. So I like to group all the controllers together, all the middleware together, all the models, and all the services together. I just think that this is a much more consistent way of grouping our application's logic. So you can see here that HTTP requests will come in via an endpoint. The request will get passed off to some middleware, and then the request will come back through the controller, down to the service, and down to the database. And then the request will come back all the way up and return back to the client. You can see in our folder here that we have some controllers. So we have a controller for our posts, our sessions, and our users. And we have a model group to match that. So we have models for posts, sessions, and users. And then same for services. We have services for posts, sessions, and users. So without any further ado, let's get started bootstrapping our application. So we're going to start with yarn init to initialize an empty project. We're going to use npx TypeScript init to initialize a TypeScript project. And we're going to install some dependencies. You can find these dependencies in the notes section of the finished repository. We're going to install some development dependencies. Again, you can find these in the notes section of the finished repository. Next thing we're going to do is to make a source directory. And we're going to make an app.ts inside the source directory. Then we're going to configure nodemon to start our application and restart every time we make a change. So touch nodemon.json and put the following script and come over to our app.ts, and we can simply console log out a message that says hello world. And we can put a script into our package.json to run nodemon, which will run our app.ts. Run yarn dev, and you can see our application prints out hello world and it waits for restarts. So if we come in here and save it, we should see the application restart, and we should see hello world get printed to the console again. So we know that nodemon is working now. The next thing we'll do is go through and create the structure for our application. So we'll make a new directory in the root directory called config. And then inside our source directory, we'll make a new directory called controller. We'll make a new directory called DB. We'll make a new directory called service. And we'll make a new directory called model. So come into the config folder and make a new file called default.ts. And this is going to be our application's config. So we need to export a default function. And we're going to set port to port 1337. You can set this to anything you like. We're going to set host to localhost. We're going to set our database connection URI. And that's everything we're going to set up for now. Come into app.ts and we can begin by importing Express from Express. We'll import config from config. And we're going to get our port and host variables from the default config with config.get and then the name of the variable. We're going to import port as a number and host as a string. So we can create our Express application by calling a new instance of Express. And because we're using a newer version of Express, we don't need to import body parser middleware. Express comes with the ability to pass JSON. So we can call app.use express.json, and this app.use is middleware that's going to be used on all routes. And finally, we can say app.listen on the port that we specify on our host. And we're just going to console log this message, server listening on our host and port. So we can run yarn dev again, and we should expect to see this message get printed to the console. And we can see that our Express application is now listening on port 1337. The next thing we're going to do is to set up our logging service. So make a new folder called logger inside the source directory. And inside logger, create an index.ts. So we'll be able to import our logger from this logger folder. And this will contain the formats for our logging. So we're going to import logger from Pinot. And then we're going to import day.js from day.js. And then we're going to format our logger with prettyprint true. We're going to omit the process ID from the log. And we're going to format the timestamp with day.js. So we can save that. We can come back into our app.ts and import the logger. And we can replace our console log with log.info. And you can see here that we've logged the timestamp with our message of level info. And so there's two main reasons that you would use a logging service like Pinot or Winston over console log. And the first reason is that you can format the messages like this. And the second reason is that console log blocks the IO. And because Node.js is a single threaded application, you do not want to be blocking the IO because it will slow up your application. The next thing we need to do is to configure our database connection. So come into this DB folder and create a new file called connect.ts. Inside connect.ts, we're going to import Mongoose from Mongoose. We're going to import our config package again, and we're also going to import our new logger. And we're going to get the DB URI from config, and we're going to get that as a string. Then we're going to create a function called connect, and we're going to export that function as default. And inside the function, we're going to call mongoose.connect. We're going to connect to our DB URI, and we're going to pass it these options here. And mongoose.connect returns a promise, and so we can call .then, where we'll log out our database connected, and we'll call .catch if the database connection fails. And if the database connection fails, we also want to call process.exit, and we'll call that with 1. So this will exit the process with a failure. So if we come back to app.ts, we can import connect from /db/connect. And once our server has started, we want to call connect. And we should see our service restart here, and we should see a message to say that we've successfully connected to our Mongoose database, sorry, MongoDB database. You can see here, database connect. So the next thing to do is to set up our routes. So we'll create a new file, in the source directory called routes.ts. And our routes file is just going to export a function, and this function is going to take an instance of our app, and the instance has a type of Express. And we can import Express from Express. So when we import Express as a named export and with a capital E, then this will refer to the interface. And we can see that as well with our request interface and our response interface. And if you command or control click those, you can go in here and you can see what this interface looks like. So if you want to see what a request objects look like, you can command click it, and then you can start exploring in here. And this is a really handy feature if you want to see what an interface looks like and what properties can be passed in there. So we're just going to have one route in here. So we're going to say app.get, and we're going to make this a health check route just so we can make sure that our application is working. And our callback will take two properties, one of request and one of response. And we can type these with our request and response interfaces that we imported from Express. And we're just going to res.send status 200. And so if our application is up and running, we should expect to see a 200 response from our health check endpoint. And a 200 response in HTTP is okay, which means our application is good and the response is what we would expect. So we can open a new terminal here and we can send a curl request to HTTP /localhost/port 1337 /health check. And we can see here that we get a cannot get /health check. And that is because our app has no idea that these routes exist. So we need to import these routes and we need to execute them while passing in our instance of our application. So once the database is connected, we can also initialize our routes and we pass in our app. We can send this curl request again and you can see that here we get okay, which means our application is up and responding to requests. Let's start building out our user registration and login process. So we're going to have a few endpoints here. We're going to have one to register the user. We're going to have one to log in. We're also going to have the route to get the user's sessions. And we're also going to have a route to log out. And because REST performs CRUD operations and uses HTTP methods, we can't have an endpoint here that says something like /API/register user, because this here is an action, but our action has to be post. So what is it that we're actually creating here? Well, we're creating a user. So our route is going to be post/API/ the resource that we're going to create, and in this case, it's a user. And when a user logs in, again, we can't have a route that's /post/login because login is the action, but so is post. This here isn't a valid REST API route. What we're actually creating here is a session. So this will be post/API/session. And to get the user's sessions, you've guessed it, we're going to get /API/sessions. And to log out, what we're actually doing is deleting a user's session. So it's going to be a delete method /API/sessions. And this here should be /sessions as well. So you'll notice that all the routes have the resource as plural. And that's because when we have the routes that are get API/posts, this will return all the posts. And as an extension to this route, we want to return one post. So that API route will be /API/posts/post ID. So if we had posts here, but post here, this would tell the user that these two things are different resources, but they're not, they're the same. So the convention is to use plural for the resource in the route. So now that we know the REST API routes that we need for our user registration, let's come over to our controller and create a user.controller.ts. And I like to put the word controller in the name, same as services and models, just so when they're in the tab, you can see what it is, because you'll see here that we have a user.model.ts. And if they're both called user, you wouldn't know which one is the model and which one is the controller. And again, for service, we're going to have user.service.ts. Let's start off with our user model. Our user model is going to have three imports. It's going to import Mongoose, Decrypt, and config. And so Mongoose is a ORM for MongoDB. Decrypt is for creating hashes, because we're not going to store our passwords in plain text. We're going to store a hash of our password. And config is to get config from the config folder. So to create a Mongoose schema, we're going to call new Mongoose schema. And then we're going to put in an object of what we want this schema to look like. And we're also going to put in some options here. And in this case, we want timestamps true. So this is going to give us an automatic created and updated date. We can then create a new user variable here, which is going to be a Mongoose model that takes our schema, and we're going to name it user. And then we just export user as default. But because we're using TypeScript, we also want to create a interface for our user. So we can create a new interface here called user document that extends mongoose.document. And this is going to have all the properties that a Mongoose document would, such as the underscore ID and version and everything. And it's going to also have our custom properties that we've defined in our schema. So to make use of this schema, we want to export our model. And if we command click on this model, we can see that here we get a generic type that extends document. So if we don't pass anything here, we're just going to get an empty schema that extends document. But if we pass our own interface here, we'll now get type definitions that include our custom properties on the schema. And you'll notice the schema here has a compare password method. So we're going to build out that compare password method now. So what this method does is it takes a candidate password. It looks for the user in the document. And in this case, it's just assigning the variable user to this, which is the user document. And then it's going to call the bcrypt.compare function, which is going to compare the candidate password with the user's password. So the user's password is going to be a hash, and this candidate password is going to be a plain text string. And so this is going to tell us if we can turn this plain text string into this password here. And if we can, then it will return true. And if we can't, we're going to return false. But we need a way to get the user's password into a hash. So we're going to call a user schema pre-save method. So you can see here that, again, we create our user from this. And if the user's password has not been modified, we'll just return next. We'll create a salt. And we need to put this salt work factor into our config, because at the moment we're calling it here with config.get. Then we're going to create a hash. And then we're going to swap out what the user gave us for the hash of their password. And then we're going to continue and save the user. Let's add this salt work factor to our config. And what salt does is add a random number of parts to the password hash. So it makes it harder for the passwords to be cracked. Come over to our user service and we'll create a few functions in here. We create a function to create a user, create a function to find a user, and we'll import our Mongoose model and document. You can see our create user function here is going to take some input, and we're going to call this document definition. And if we command click on this again, so if we import this and then we can command click on it. So we're going to import document definition from Mongoose. And we can see again, this is a generic type. So we can pass our user document into here. And this will give us some nice type definitions when we go to call create user. We can see an example of that here. So we can say create user. And we can see the properties here that we can pass into create user. And we're going to try create the user. And if it returns an error, we're going to throw that error. Otherwise, we're just going to return the new user. And the reason this might throw an error is we have a unique condition on our email. And so if the email has already been taken, we're going to get a duplicate key error. And we're going to be able to return that error back out to the user. So before we continue, let's go over to our user model. And we can build out our create user handler. So we're going to export a function called create user handler. And so this is going to be export async function, because we're going to be using async await in this function. And we're going to create a try catch block again, because we have that unique validation on the email. We might get an error here. We need to import create user from our user services. And our controller handler is going to take two properties, and that's going to be the request and response. And again, these types come from Express, so we can import those from up here. And we're going to call our create user function with our request body. And this request body here at the moment could contain anything. So we need to validate this request body, and we'll get to that with Express middleware. So if this function succeeds, we're going to call res.send, and we're going to emit the user's password from the response. And this emit comes from Lodash. And if you haven't used Lodash before, it's just a utility library that contains lots of useful things. And in this case, we're going to use the emit function, which takes an object and then an array of properties or a single property that you want to emit from that object. The alternative to that is to call delete, but you should generally try avoid deleting because it mutates a object. And then if we encounter an error, we're going to call res.status 409, which is a conflict, and we're going to send error.message. So the most likely scenario here is that somebody tries to register with an email address that's already taken, and in that case, it's going to be a conflict. And we also want to log out the error here. So we're going to import log from our logger, and we're just going to call log.e. So the next thing to do is to build the handler for this route. So this is going to be app.post/users/API/users. We're going to have this validate request middleware, which we'll build out now. And then we're going to call this create user handler, which we need to import. So we're going to start building out our middleware. So create a new folder called middleware. And we're going to create a new file called validate request.ts. And to validate our request, we're going to require a schema. And then the function is going to take in the request, response, and the next function. We're going to try validate that schema. And if it succeeds, we're going to call next. And if it doesn't, we're going to log the error and we're going to send a 400. And if you haven't seen this syntax before, basically what we're saying is we're going to initialize this function here with one parameter, but then we're not going to execute the function until we receive the rest of the parameters. You can see here in our route, we initialize the first part with this validate request call here, and we pass in the user schema. And then when the route gets hit, we call this part here. And this method is called currying, and it comes from functional programming, and it is very useful and definitely worth looking into. So we're going to import validate request from our middleware. And you can see here that we also have a schema that we need to define. Let's make a new folder for our schemas. And we'll create our create user schema. Actually, let's create user.schema.ts. And we'll, like our services and controllers, we'll store everything to do with user in this one schema. So you can see our create user schema here is a yup object. So we're just importing object, string, and ref from yup. And we're going to create a new object here. And our request is going to be, the portion of our request that we want to validate is in the body. So that, again, this is another object, and we want to have a name. And if the name is not present in the request, we're going to send this error here. So it says name is required. And then we're going to set some rules for our password. So we can say that it needs to match this regex here, which just says that it needs to include either letters and numbers. So it will only contain Latin characters. It needs to be at least 6 characters long, and it's a required string. And our password confirm needs to be the same as our password. And if it's not, then we're going to return this error here, passwords must match. And our email must be a valid email, and again, it's a required string. So we need to import our create user schema, pass it into our validate request. So once we've saved this and our server has restarted, we can come back over to Postman, and I've deleted the user that I created earlier. We can resend this request and we see we get a new user here. So that's our first route complete. So the next one we're going to do is to log in. So if we create this route here, we can see again that we have a validation on the request. And in this case, it's going to be create user session schema. And we're going to call the create user session handler. Let's import the handler from our controllers, and we'll import the schema from our schemas, and we'll go in and we'll create this handler. Again, this is an async function that takes 2 parameters, request and response. There's a couple of things to note here. All of our controllers are going to take the same parameters, request and response. And our controllers are never going to interact directly with our database. That's what our services are for. So this means that we can separate our database logic from our business logic. And in this application, it's quite simple. Your application might get more complex, and you'll be thankful that you separated those two concerns. So let's work out what we need to do in our create session handler. So we're going to take an email address and password, and we need to validate that the email is registered and the password matches that registered account. We need to create a session. We need to create an access token, and we need to create a refresh token. Then we're going to send the refresh token and access token back to the user. Before we continue, let's move this into a session controller because sessions and users are two different objects. And this here is creating a session and not a user. And because sessions and users are two different objects, we also need a sessions service and a sessions model. So come in and create session.model.ts. And our session model is going to look a lot like our user model. So you can see here that we have our session document that again extends mongoose.document. And then this time we're going to also import the user document because the user on the session is going to reference the user's ID. So we could say here that this is a string, but it doesn't really tell other developers where this string comes from. Where if we say this, it tells other developers that our user refers to the ID on our user document. We're going to have a valid Boolean, we're going to store the user agent string, and because we have this timestamps true, we can also access created and updated at. And our user is also going to reference a Mongoose schema types.object ID, and it's going to reference the user. And again, we're going to export our model with our session document, and we're going to call it session, and we're going to export it with our session schema. And this here should be session. So let's come back to our session controller, and we can see here that we need a validate email and password. So this looks like it should be a service. We need to create a session. Again, we need to create that in our services. We need to create an access token, and for that we need to sign an access token. And it doesn't really interact with our database, so we're going to create that as a utility. And the same as refresh token, and then we're going to send the refresh and access token. So let's create a session service. We're going to create the function to validate the user's password inside the user service. So you can see here that we have a function called validate password, and it's going to take two properties, an email and a password. It's going to try find our user by the email address. If it can't find the user, it's just going to return false. The email or password is incorrect. Then it's going to create this isValid variable, which is going to be a Boolean, and it's going to call our user.compare. And this is because on our user schema, we created this compare password function. One thing to note about this is that if we call .lean on this user find, we'll no longer have access to this user.compare password. So we can't call lean here. And if it isn't valid, we're going to return false. And if it is valid, we're going to return the actual user, but we're going to omit the password. So let's import this omit from Lodash again. And this is our validate password function. Come back to our session controller. We can call our validate password service. First, we need to import it from the user service. We're going to create a new variable here called user. Just remember our validate password function returned a user or false. So we can say here, if not user, return a status of 401 with a message that says invalid username or password. You can see we're getting some errors here because request and response hasn't been imported from Express. So we can import those at the top here, and we should see those errors go away. So the next thing we need to do is to create a session. So if we come over to our session service, we can create a function to create a session. We also need to import our session model and document. And in our controller, we can import our session, create session service. And to create our session, we're going to pass in the user's ID. We're going to pass in the user agent. And this function here will create a new session with our user ID and our user agent. So you saw before that our user agent was Postman. If we were to make that request from a browser, our user agent would be something else, say something about Mozilla. And if we were to make that request from a microservice, we would set the user agent to the name of that microservice and its version, and so we could log where requests were coming from. So our next thing to do is to create an access token. So let's come over to our session service, and we're going to create a service in here to create an access token. So you can see that our access token our function will take two properties, our user and the session that we created. And we can import this user document from Mongoose. So we can import this from our user model. We also need to import config from config. And so this function here will expect a user with the password omitted from it, or it will expect a lean document with the password omitted. So this lean document means that we can pass a user in here that has been found with .lean, or a user that has been found without calling .lean. So we need to import this lean document from Mongoose. And same with session. We can either call this with a session that has been found without lean or with calling .lean on the find function. And we can see here that we have this sign function that we need to create, and this is going to sign our JSON web token. And it's going to put this object in here, and it's going to create it with this option here. So this is a expires in, and this is an access token time to live. We're going to make this about 15 minutes. We'll just make a comment here. And the reason this is so short is something that I will explain when we get to refresh tokens. Let's create this sign function here. Let's create a new folder called utils, and we'll create a new file in here called jwt.utils.ts. And we're going to create this sign function. We need to import config from config. We need to import JWT from our JSON web token package. And we also need to create this private key. Let's create it as an empty string for now. Actually, we'll create it as a config.get, and we'll put this in here. This is going to throw an error for now, but we will put our private key into our default config. And we're going to allow some options here. And so I got this type here by clicking on this json.sign. We can go into the type definitions here, and we can see that it has a sign options. And so I imported the sign options from JWT, or it can be undefined. And then this will give us some nice typings when we go to use this sign function. So we now need to import our new sign function from our JWT utils. And you can see here now that we're going to get a signed access token. So this is our create access token function complete. We can come back to our controller, and now we can create our access token. And we need to import our create access token from our session services. And to create our refresh token, we're just going to create our refresh token, we're just going to call our sign utility with our session object, and we're going to make it expire in about a year. We'll add a comment here that just says 1 year. And we need to import config and our sign utility. So you may be wondering, why have I extracted this create access token out into a service, but the refresh token is just created with our utility. And that's because the utility is good enough to just be called directly with our session object, where the create access token needs to have the two combined and a little bit of logic applied here. So let's go to our config, and we need to add these properties. So we need to add an access token, time to live. we need to add our refresh token time to live. And we also need to add our private key. So you can see here that our access token time to live is 15 minutes, and our refresh token time to live is going to be 1 year. And then if you go to Google and type in generate private key, you'll find a website where you can generate a private key, and then you can copy and paste that into your config file. But this private key I will upload to the repository, so you can just copy this if you like. But make sure you're not submitting your private keys to repositories and storing them online if they're going to be used to actually sign real refresh tokens and JWTs, because that is very insecure. So we're back at our session controller and we've created our access token and our refresh token. So now we're just going to return from our function here, res.send, and we're going to send the access token and the refresh token. So you can see that our server is still crashing, and this is because we don't have our validation schema set up. You can see here our create user session schema is not exported from our user schema. So let's come into our user schema. And we'll create our session schema here. So again, we're validating the body of this request, and we expect there to be a password with the same rules as our password up here. And we expect there to be a valid email and our email to be required. So we can save this schema. And before when we moved our session handler out into the session controller, we didn't move the import, so we're going to import it from the session controller. And you might be thinking there's a lot of back and forth between files and a lot of jumping around. And that's true. And it's true for the start of every application. And as you build out more and more of these services, you don't need to jump around. And so once we've built out the JWT services, for example, we don't really need to open that file again. And same as these services files, once we've built those out, we can start reusing different components of those services. So now our server has restarted successfully. We can go back to Postman and we can create a session and see if our handler works. And you can see here that we get a new access token and a new refresh token. But what does that actually mean? What can we do with this access token? And what does a refresh token do? So let's have a look at the... So you may have noticed that our access token only has a time to live of 15 minutes. And that'd be quite annoying if you have to log in every 15 minutes. But we also have no control over who is logged in. So if we want to log a user out, then we can't, because so if we make our access tokens longer, say a year, we can't log those users out because our application is stateless. So there's a problem. We either need to make a request to the database every time the user makes a request, or we have our application stateless, or we use refresh tokens. And so when the token has expired, we will check to see if it's an expired token, and then we'll check to see if the token was valid. And we'll check to see if they have a valid refresh token. And if they do, we'll reissue a new refresh token. And if we have a look on our session model, you'll see a valid, and we're going to check this valid to make sure it's still true. So if we want to log a user out, we can set this to false and it will invalidate their refresh token. And when their access token expires, they won't be able to get a new access token and they'll be logged out permanently. So this gives us the best of both worlds. We get stateless requests for 15 minutes, and then we can validate the refresh token to let the user's session keep going. So we're going to do all this with some Express middleware. So come into the middleware folder and create a new file called deserialize_user. And we're going to have a look at what this function does. So we're going to get the access token out of the request headers. So we're going to put this in headers.authorization, and that's where access tokens always go. We're going to have a custom header called xRefresh, and that's where our refresh token is going to be. And if there is no access token, we're just going to return next. If there is an access token, we're going to try decode it. And if we can decode it successfully, if the access token is used within that 15-minute window, we're going to append the user to the request object with the decoded token. And then we're just going to return next. And this is where the refresh token logic comes in. So if the token is expired, and we can see that from this decode function that we will need to create, and there's a refresh token, we're going to call this reissue access token function, which we'll also create. And then we're going to see if there is a new access token. And if there is, we're going to set it on a header so the user can reuse it. And then we're going to decode the access token. And then we're going to append the new body of the access token to the user object. And this means that in our handlers, we can call rec.user. Then we're just going to return next. And so we can pass through this middleware. So let's create our decode function in our JWT util. So our decode function here is just a wrapper around jwt.verify, and it takes our token and our private key, which we have set in config, and it returns this object here. So we're just going to say if it's valid. We're going to say if it's expired. In this case, if it's valid, it hasn't expired. And we're going to return the decoded version of the token. If there is an error, we're going to say the valid is false. We're going to set expired to true if the error message equals JWT expired. And we're going to set decoded to null. So if we come back to our deserialize function, we can see that we also require a reissue access token in our session services. You can see our reissue access token function here is going to try decode our refresh token. And if we can't decode our refresh token, then we're going to return false. We're going to try find the session that is in the refresh token. And if the session is not valid, again, we're going to return false. We're going to try find the user, and then we're going to create a brand new access token. So let's import decode and get and find user. So decode comes from a JWT utils folder. And you can see here that we're already starting to reuse things that we've created before. Get comes from Lodash. Again, get is a very helpful utility function that will allow us to get properties without the risk of get is a very helpful utility function that will allow us to get properties from functions without getting errors. So if we try to get ID from decoded and decoded is null, then we'll get an error because you cannot get ID from property undefined. So you can also use the nullish coalescence syntax. So you could say decoded.id, but I prefer to use Lodash because I like the syntax a little bit better, but you can use what you like. And we also need to import this find user method from our user service. We also need to implement our find user function in our user service. So again, we're going to export an async function. And our query is going to be of type filter query, and it's going to take our user document. And then we're going to call user model.find1 and then pass our query in and .lean. And there's a special trick to creating these services. You want to create them specific enough that they're useful, but you also want to create them generic enough that you don't have to create a bunch of services that do roughly the same thing. And so I find this is a nice in-between ground where we can pass in whatever the query is that we want, but we're also not tied to one query. So if we made a service, for example, that was find user by email, and then we wanted to find a user by their name, we would need to create a new service or refactor our existing service. With this service here, we can do both. And we're going to get some nice, helpful TypeScript helpers as well. We also need to import the filter query generic type. So now that we have our deserialize user middleware implementation done, we need to create our logout route. And our logout route is quite simple. All it's going to do is invalidate a user session. So let's create this invalidate user session handler, and we're going to import it from our session controller. And again, we're going to export an async function. It takes two properties, request and response. And we need a service to update a session. So we don't have one yet, so we'll go and create that. So our update function takes a query. So this will be used to find the document that we want to update. And then it'll take an update query. So this will be the body of the update. So come back to our session controller, we can import our update session service. And you can see here that we're getting our session ID from the request.user.session. And so we need to add this functionality. So we need to import get. Import get from Lodash. And the reason that we can get our session ID from our request.user object is because in our deserialize function, you can see that we attached it to the request. And this access token also includes a reference to this session ID. And then we call our update session service. And then we're going to return a status of 200 because the user has been logged out successfully. And you can see here that we're using this require user middleware, but we haven't actually created this middleware yet. So let's go ahead and do that. Come over to the middleware folder and create a new file called requireuser.ts. And I'll show you a nice little import export trick here with JavaScript. So we can create a index.ts. And in our routes, we have all these imports for middleware, and we will have a new one here. So we'd have 3 lines here, but if we just want to import all of this as named functions from the middleware folder, we can do that in here. So we can say export and then create a named export as default as whatever we want to call it. So we can call this one deserialize user. And then where we want to get that function from. So what this is going to do is import the default function from deserialize user, and then it's also going to export it as a named export. And we can do the same with require user and validate request. And we haven't implemented the required user middleware yet, which we'll do now. And so this is going to take a request, response, and next. And if we compare this to our validate request function, they look a little bit different. You can see here that there is 2 functions here. This is our schema, and then the next function here takes our request, response, and next. And in this case, the first function here is going to take the request, response, and next. And that's going to determine how we actually use this middleware. So this is going to try get the user from the request object. And if the user doesn't exist, we're just going to send back a 403. Otherwise, we're going to return next. And the reason that user will exist in this is because we've called this deserialize user. In fact, we need to go into our app.ts and we need to call this deserialize user on all routes. So if we come into app.ts, we can import our middleware and we can say app.use and then pass in our deserialize user function. So this will attach our user to every single request that comes into the application. And I've tried to import update session from the user service. So now that we have our logout route complete, let's go over to Postman and test it out. We need to log in. We need to get our access token and update our Postman's environment variables. Update the refresh token as well. And we can try delete our user's session. So we click res.send, we get an OK. If we have a look in our database, and sorry, I can't get Robo3T to zoom in, so it is a little bit small. But we can see here that our session is valid false because we've logged out. So the last thing to do for our sessions is to get a list of the user's sessions. And the reason that we would want to do this is because if the user wants to see where they've logged in and when they've logged in, we'll be able to show that information, and they'll be able to destroy sessions if they like. So if they are logged in on a device that they don't recognize, they'll be able to log out from that device. So the handler for this is going to be /API/sessions. And again, we're going to require the user. And we have a get user sessions handler. And we have a get user sessions handler, which we will now create. We will import that from our sessions controller. Come over to our session controller and we'll create the handler. You can see this handler is very simple. It's going to get the user's ID from request.id. And we know this is going to exist because we've used the requires user middleware. We're going to find the sessions that belong to this user and that are valid. So we need to implement this find sessions service. So if we come over to our sessions.service, we can implement this. And again, this function is going to be very simple. It's going to take a query of type filter query, and we're going to query the sessions model, and we're going to call .lean. .lean is going to return a smaller document without all the Mongoose stuff attached. There's some good documentation on .lean on the Mongoose documentation website. And that is our get sessions endpoint complete. So we'll come over to Postman and test it out. So if we send this request, we can see that we are logged in once. If we create a few more sessions, we should see a few of these objects in the array. And you can see that we've logged in a few times now. So that's it for creating the user registration part. The next part, we're just going to be creating a post model, and then we're going to be able to create posts, update posts, and read posts. So come back to our routes, and the first route we're going to create is to create a post. And so it's going to be app.post/API/posts. And we have 2 bits of middleware in here. And so we put these middleware in an array. And so we're going to require that the user is logged in, and we're going to validate the request body. And we're going to create a create post handler. The next route is going to be to update a post. So this is going to be similar to the create post route, except we require a post ID, and the request is going to be a put request. And we're going to have an update post schema, and we're going to have an update post handler. The next route we have is to get a single post. And so we require a post ID param, and we're going to use the get post handler. And we have no middleware for this route because we don't need the user to be logged in, and there's no request body that we need to validate. And the final route is to delete a single post. So again, we're going to require that the user is logged in, and we're going to validate the post request body. So let's create these schemas to validate these requests, and then we'll create the handlers. So create a post.schema.ts. And we have a few validation schemas in here. So we have one for creating a post, updating a post, and deleting a post. The body for creating and updating a post is the same. So we've abstracted this out into a different variable called payload. And then we're just going to spread that payload into the body of the schema. But to update a post, we require that the param includes a post ID, and the same with deleting a post. And we could abstract these out into a different variable as well. So we could extract the params out into its own variable, and then we could spread that onto this payload like this, and this will make our schemas just a little bit tidier. So now we're ready to create our handlers. So come over to your controllers and create a post.controller.ts. And we can split our window so we can look at our routes and see what handlers we need. So we need a handler for creating a post. So we'll export an async function. And this async function, again, takes request and response. And we can copy and paste this a few more times so we can just copy the names of the handlers from our routes. And then if we come back to our routes and make sure we've imported all these handlers, now we're ready to fill out each one of these handlers. So to create a post, we're going to get the user ID from the request object. We're going to call a create post service. And then we're going to send the post back to the user. So we need to import get from Lodash. And we need to import this create post service from our post services. And we're also going to need to create the post service. So come over to your services folder. And our create post service is just going to take an input that is document definition with our post schema document, our post document schema. And then we're going to call post.create with our input. So now we've imported our create post handler. We're ready to go to our update post handler. So our update post handler is going to call a find post service that we're going to need to create, and a find and update service that we also need to create. If it can't find the post, then it's going to send back a 404, which means if it can't find the post, then it's going to send back a 404 not found error. So we'll import find post, and we'll import find and update, and we'll implement those methods. So find post is going to take two inputs. It's going to take our query, and that is of type filter query with our post document. And it's going to take options, and it's going to have a default set of options here with lean true. So when you use this service, you can specify lean false if you want to use the document. If you want to use the Mongoose functions on the document. And so we pass this empty object in here because this is the projection object, which we want to leave blank for now. So our find and update method will take a query to find the document, an update query, and some options. So the next handler we need to implement is the get post handler. And our get post handler is going to get the post ID. It's going to find the post, and then it's going to send it back to the user. But we're just going to say in here, if not post, then send back a 404. We also have a small problem with our update post handler. So if the user is trying to update a post that doesn't belong to them, they're going to be able to do so if they're not logged in. So we're going to do a quick check here to say if post.user is not equal to user ID, then we're going to send back a 401, and we're just going to cast the user ID from post to a string to make sure that it's going to match the string type of user ID. And we need to get the user ID from the request object. And with that small check, we've saved ourselves a lot of headaches. So the last handler we need to implement is the delete post handler. So delete post is going to get the user ID, the post ID from params. It's going to try find the post. Again, if it can't find it, it's going to send back a 404. It's going to check that the requesting user belongs to this post, or the post belongs to the requesting user. It's going to call this delete post method, and then it's going to send back a 200 request. So we need to implement the delete post. And so delete post just takes a query to find the document, and then it will call delete one and delete the document. And that is our post CRUD operations complete. Let's go over to Postman and make sure it all works. So we're going to log back in and get a new access and refresh token. You can use your refresh token to get a new token. and you will get the new token in the response headers. But it's easier here just to log in again. So we're going to replace this access token. And now we can create a post. So you can see our new post here, and we can replace our post ID with our new post's ID. Now we can get our post. And you can see our post document is returned here. And finally, we can update our post. So we can say this is a new title. And we get our new title here. And finally, we can delete our post. And our post is gone. As always, thank you for watching. If you have learned something, please like the video and subscribe to my channel. And you can find the GitHub repository in the description.